Okay, we're going to be graphing g of x is equal to negative x squared, and you're going to notice a lot of similarities from our last graph, that f of x is equal to x squared. First, we're going to start substituting our values for x. So our first value we're going to substitute here for x is going to be a negative 2. So g of negative 2 is going to be equal to, and we're going to put a negative on the outside of the parentheses, and then we're going to square first the negative 2. Okay, so order of operations says exponents go first. I'm going to multiply negative 2 times negative 2 first, and I'm going to get a positive 4, and then I multiply with the negative on the outside, which gives me that negative 4. So there's our first ordered pair. Next, we're going to substitute negative 1 for x. So it's going to be g of negative 1. I write the negative outside from the equation, and then I substitute the negative 1 inside the parentheses. I'm going to have negative 1 squared first, so it'll be negative 1 times negative 1 first. And then I'm going to multiply it with the negative that's on the outside. Give me negative 1. G of 0 is going to be negative times 0 squared, but 0 squared is just 0 times 0, so there's no such thing as a negative 0. 0 is a neutral number. It cannot be positive, it cannot be negative, so we're just going to write there 0. Okay, next we're going to substitute 1 for x, so g of 1 is going to be negative times 1 squared. So we'll square the 1, so that'll be 1 times 1, and then we'll multiply with the negative. So it'll give me negative 1. And the last value we're going to substitute for x is 2. G of 2 is going to equal a negative times 2 squared. 2 squared is just 2 times 2, which is a 4, and then I multiply with the negative, and that gives me negative 4. Okay, you're going to notice that this graph is going to look a lot like the last graph we did in part 1, but the difference is that this this graph looks like it was reflected over the x-axis. If we compare it to our last graph, our parent graph. Okay, every time we have a quadratic function where our x squared term is negative, it's always going to end up opening downward. I'm going to draw the last graph I did from part 1 right above it so you can see, you can compare the two. And you're going to notice that it's a clear reflection of this parent graph across the x-axis. Every point that is on our parent graph, it's like a mirror image on the other side of the x-axis. So the orange dotted graph is f of x is equal to x squared, whereas the black solid graph is going to represent my g of x, which is equal to negative x squared. That way you can see the similarities as well as the difference. I'm going to highlight the points so you can see how they are a mirror image of each other. They are the same distance from each other across the x-axis. So if I were to measure from the x-axis, I would notice that They are the same number of units away from each other. Okay. So I think that's a clear visual of seeing that they are same number of distance from the x-axis from each other. It is a reflection across the x-axis.